Hi, it's Carly McAvoy. I'm continuing to talk about probability and odds. And when I talk about that, I ended up talking about casinos and racetracks and cards and dice because that's the genesis of probability. It came from people who were gambling. And now people do things that we don't think of as gambling, but it really is something like giving insurance. If you give insurance to somebody, you're gambling on whether or not you think they'll have an accident. So probability plays a part in our life, even if we don't make it to the casinos. This is a picture of an actual roulette wheel and the betting choices that are available when you bet. In general, the house advantage or house edge for roulette is 5.26%. For craps, it's 1.4%. For slot machines, the advantage can vary widely from 2% up to 24%, really. So what does it mean when that house advantage or house edge is 5.26%? What it means in roulette is that for every dollar bet, the house keeps a little over 5 cents. We can say it's 5%, and they keep 5 cents out of every dollar. So people do win, but they have it set up so they're every dollar that's bet, and that's a generalized thing. So maybe $1 they win all of it, another dollar they don't win any, another dollar they win 27 cents or whatever. But in general, they have it set. The odds are set so that the house will win 5 cents out of every dollar anytime somebody plays. So they're guaranteed to win something, and sometimes they'll win more than that. Okay, so I wanted to explain what that was before we did the next problem where we're just talking about a roulette wheel and you're like, what? Notice the roulette wheel goes up to the numbers 36. And then, anyway, so in this one, our modified casino game. So a modified game of roulette has the numbers 1 through 28, 0 and double zero. There's always 0 and double zero in roulette, and they don't count as odd or even. If you bet on an odd number and the ball lands on an odd number, the casino would consider that a push, and a push means 1-to-1 odds. So first of all, what are the odds against winning when you bet on an odd number? Odds against, you put the unfavorable event first, followed by the number of favorable events. Well, in 1 through 28, there are 14 odd numbers. So that's our favorable is 14. But we have 1 through 28 plus 2 more. So we actually have 30 events in our sample space, 30 different things that could happen. So our odds against 16 times it would not happen, and 14 times it would. So we have 8 to 7 is our odds against winning if we just bet on an odd number. If you bet $10 and an odd number comes up, what would your payout be? Well, a payout of even is just you get your money back. So if you bet $10 on odd and it comes up to be odd, you get your $10 back. That's what they're paying you because they're saying that's 1-to-1 odds. That's what they consider it. But if they paid actual odds, what would your payment be? Well, in actuality, what they should be doing is taking the unfavorable and dividing by the favorable events to get a dollar amount, to get that decimal amount. So if we take 8 divided by 7, you should be getting $1.14 or 114% of your bet, basically. And so if you take your $10 times $1, it's not money, it's percent, sorry. It's 114% of your bet, all that you got back plus 14% more, and that would be $11.40. Okay, so that is what it should be. They should be paying you $11.40. They do pay you $10, so they're automatically setting that up to where they get a pretty good payout. I'm going to go ahead and mention independent events while we're here because we have time. Independent events are 2 events where the occurrence of one does not affect the probability of the occurrence of the other. So good examples are dice or coins. If I roll a dice twice, if I get a 5 the first time and now I'm getting ready to roll again, I still have the same likelihood of getting a 5 or any of the other numbers. So my first roll, it doesn't matter. Same thing with the coin. If I flip a coin and I get heads, then I might flip again and get heads again, or I might get tails. Every single time I flip a coin, I have a 50-50 chance of either one. So those are independent. Having gotten a heads the first time doesn't affect my chance of getting it the second time. But where we could have an independent, let's look at this other example. Let's say that I have 10 people, and I'm going to select 2 of these people, and I'm going to give them a prize, okay? And so originally, when I'm going to select 2 out of 10, they all have a 2 out of 10 or 1/5 or 20% chance of winning, right? So I take one person out. So I picked the girl in the gray here. She won. So she's gone. Now I'm getting ready to pick the second person. But notice now I'm going to pick one person and there's 9 people left. And now they don't have a 20% chance. Now they have a 1 in 9 chance, which is about 11%. So after the first person got chosen, their probability of winning went down. So those are not independent events. By removing this girl and then leaving everybody else to win the second prize, those are considered to be dependent events. So a dependent event means that the first thing happening changes the probability for the second event. Another way to get to two events, that should be TWO, 2 events to be considered to be independent is if you have a very large population to start with. If I'm going to choose 2 people from Seattle to receive free gas for a year, then I would have over 700,000 to choose from. In this case, removing one person would not significantly affect the probability of everyone else, so the events would be considered independent. Even though I haven't replaced anybody back, so I took somebody out, I did change the population, but that population is so large that we would consider that to still be not affecting anybody significantly. So if the population is large enough, then we don't have to worry about the independent event rule. All right, have a fantastic day, and I'll see you next time.